Thanks for taking the time to watch the VMware NSX Network Virtualization demo. To preface the demo, I'd like to take a few minutes to review what a virtual network is, to be sure we all have a good understanding of what we are provisioning in the following demo as we create virtual networks, attach VMs, add virtual routers, and distribute security profiles. A virtual network is a complete network in software. It may consist of multiple logical switches, or L2 segments, each spanning across physical subnets and availability zones to reach compute capacity wherever it's available. Connected workloads, VMs or physical servers, support existing applications unmodified and see the virtual network as a physical network. Virtual networks provide all of the network services a connected workload expects: Layer 2 switching, Layer 3 routing, and Layer 4 through 7 network services, including ACLs, QoS, firewall rules, load balancing, VPN, and more. In this diagram, you can see that as a communication moves through a virtual network between two VMs attached to different logical switches, a logical pipeline of network services is applied, in this case utilizing L3 routing without leaving the virtual network to reach the other VM. So how does a virtual network operate as an overlay on your existing infrastructure? In this diagram, you can see the physical servers connected to the physical network as they are today. Each physical server in the diagram has a hypervisor and a vSwitch. Imagine a logical switch has been provisioned for the green VMs. When the green VM on the left was provisioned and attached to the logical network, the NSX controller pushed the network services for that VM to the vSwitch on the left. Likewise, when the green VM on the right was attached to the logical switch, its network services were pushed to the vSwitch on the right. When the green VMs communicate, the actual packets flow from the VMs through the rules provisioned for those VMs in each of the vSwitches. Distributed firewall rules, for example, would be enforced at this point. If the packet makes it through the ingress rules, it is encapsulated and forwarded through the physical network, across subnets and availability zones to the destination hypervisor, where it is decapsulated and passed to the hypervisor's vSwitch. Egress rules are applied and the VM receives the packets as if it was connected to the same physical switch as the first VM. When a VM moves, its network services move with it. You can provision thousands of virtual networks. Each virtual network is isolated from every other virtual network and from the underlying physical infrastructure, and supports overlapping IP addresses. So, for example, you could deploy virtual dev, test, and production networks all at the same time, all with the same IP addresses, and all on the same physical infrastructure, allowing you to utilize any available compute within a single data center or across multiple data centers, and repurpose generalized physical infrastructure on demand by eliminating the need to manually reconfigure and troubleshoot VLANs, ACLs, and firewall rules in the physical network. Okay, with that background, let's get to the demo.
Hello everyone, this is the Openstack Horizon dashboard which we have in front of us. This is basically our front end that we give to our Openstack users. Whenever I log into my Openstack dashboard, I am a tenant on my Openstack cloud, and I have the following properties available to me. I have up to 15 VMs that I can create. I can create these VMs with as many as 20 virtual CPUs. I can go ahead and launch 50 gigs of RAM, and so on and so forth. I can also see my active usage of what I've been using in July and in the previous months as well. This environment right now is a blank environment, and I want to go ahead and demo how I can create a multi-tiered application and demonstrate the connectivity between my VMs in the same tier and also amongst different tiers or different logical switches. As we go through the demo, we will go ahead and spin up the networks, launch the logical components of the networks. We'll create a logical router to give my tiers connectivity to each other, and we'll also show how security profiles are implemented in our cloud. Let's go ahead and get started and take a look at the network topology of what we have available to us. At this point, the network topology is blank. The three pipes that we see over here are my uplinks that are available to all of the users and all the tenants in our cloud. These are my path out of the cloud. In order for me to get started with my workload, I need to create my own networks. So I'm going to go ahead and click on the Create Network to launch a logical switch. We'll call this logical switch Tier 1. And we're going to go ahead and give it a subnet of subnet A, and we'll call it 192.168.1.0/24. Now, this IP addressing on my network is something that I can choose on my own. In my cloud, we allow for overlapping IP addresses, so all of the tenants are in their own sandbox, and they can create a multi-tier application with the same IP schema if they wanted to. We leverage Openstack namespace support for this functionality, and I can go ahead and create a 192.168.1.0 for this logical switch, and not have to worry about it clashing with any of the logical switches in my Openstack cloud. So I'll go ahead and hit Create over here to launch my first tier. So this is a logical switch. You can see that I have given it the 192.168.1.0/24 subnet. And now I am ready to launch instances on this logical switch. If you go back to the Networking Topology tab, we will see a fourth pipe over here. And this fourth pipe is my logical switch that I just created, which I called Tier 1. Now that we have this created, I can go ahead and launch instances. And I do this simply by clicking the Launch Instance button on top of my Network Topology page. And I have the OpenStack Horizon Launch Instance pop-up available to me. Over here, there are a few properties that we need to specify for each VM. I'm going to go ahead and select from a host of VMs that I have in my Glance repository. These are all the images that are available for me to build a VM out of. Alternatively, I can also select from snapshots that I may have previously saved of a VM. We'll go ahead and choose the image option for now. And I'm going to go ahead and pick the Ubuntu 12.04 desktop image for the purposes of this demo. So we're going to call this VM Tier 1 VM1. And we'll go ahead and give it a little more CPU and memory. And I will go ahead and click on the Networking tab first. And this is where I give my VM its network properties. So this is going to go ahead and drag over here, and I'm going to give this VM its NIC card. So at this point, my VM has one NIC, and that NIC will fall into the Tier 1 logical switch that I previously created. I also need to go ahead and give this VM a security group, and I'm going to keep it in the default security group for now that I have created in my Horizon Cloud. So we are ready to go ahead and launch our first VM. So we can see this is a VM that I've launched. The flavor that I picked was a 4 CPU, 4 gigs of memory on this VM, and we are now in the building and networking state. And by default, my VMs will get an IP address because I have a DHCP agent running on all of my logical switches. This is a property that you configure in Quantum to allow or disallow DHCP components on your logical switches. So this VM automatically got the IP address of 192.168.1.3. We'll go ahead and do the same thing for the second VM that I create on this switch. So pick the Ubuntu 12.04 desktop image, call this Tier 1 VM2, give it some more CPU and memory again, and also put it in the same logical switch. So now I have two VMs on a logical switch. One of them will get the 192.168.1.3 IP address, which is my first VM, and this VM should get the 192.168.1.4 IP address once it is done spawning and networking. And there we go. If I go to my networking topology page, I can verify the same actions that I've done by taking a look at the topology over here, and I should have two VMs on my Tier 1 logical switch. So there we go. We can now see that we have our Tier 1 with the two VMs, and the IP addresses for the VMs are actually displayed on the networking topology page as well for an easy visual representation of what this looks like. I should be able to console into the VMs over here and ping each other, and which we will go ahead and demonstrate as well. So if I click on Tier 1 VM1, and I can click on the console for that VM, let's go ahead and pull it up. Let's go ahead and open up the terminal and verify the properties. So this VM was VM1, so it does have the IP address of 192.168.1.3, and its neighboring VM is 192.168.1.4, and they can ping each other. So we created a logical switch with a couple VMs on the same layer 2 broadcast domain, and they can ping each other. Now we're ready to go ahead and deploy another tier. And we do the same thing by going back to the networking topology page and launching another logical switch. So I go ahead and click on Create Network, and we'll go ahead and call this Tier 2, give it a subnet 2, and I'm going to put this tier on 192.168.2.0/24. Our first one was on 192.168.1. This one will be on the .2 subnet. And we'll go ahead and create this. So now we have two logical switches, and we're ready to launch VMs on our second logical switch as well. So we'll go back to our networking topology page and click on the launch instance to put VMs on this tier 2 logical switch. And we'll do the same thing we did in the first step, or first tier. So we'll call this tier 2 VM1, give the same CPU and memory, and put this guy on tier 2. So this guy will get a NIC interface on the tier 2 logical switch. And I'll launch one more, so I have a pair of VMs on each logical switch. Alright, so we can see, similar to our first tier, these VMs also got IP addresses automatically. We got the 192.168.2.3 IP address for our tier 2 VM1, and we got the 192.168.2.4 IP address for our tier 2 VM2. And same as our tier 1 VMs, these will be able to ping each other as well. So let's go ahead and quickly verify that by going to the console of my tier 2 VM1. Now you can see there's multiple ways to get to the console and to get to the launch instances and launch networks pages. It's just depending on where you are, you can go ahead and console into the VM from multiple locations, which makes it very convenient for me. So we are now consoled into the tier 2 VM1, and I'm going to go ahead and open up the terminal and verify the IP address of this guy. He should be 192.168.2.3, and indeed he is. And I'm going to go ahead and ping his neighboring IP address, 192.168.2.4, and that works as well. If I try to ping the 192.168.1.3 IP address, obviously these guys are on different layer 2 broadcast domains, different layer 3 subnets, so they can't ping each other. We don't have a default route for this guy to get to. Default routes are done by adding logical routers, which we will get to next. So in order for tier 1 and tier 2 to talk to each other, we need to go ahead and launch a logical router. And logical router is launched by creating this router on this top right. I click on Create Router, and it will pop up an option for the router name, and we're going to give it a router name of Interconnect Router. And we'll hit Create. Now that I have a logical router created, this logical router does not have any ports. So I need to go ahead and first give it ports into each of my tiers or my logical switches. So I click on the router and click on the Add Interface of the router, and I go ahead and select the interface that I want to add a port into. My first interface will go into the tier 1 logical switch, and my second interface will go into the tier 2 logical switch. So now the router automatically got the IP address of 192.168.1.1 and .2.1 in each of its respective logical switch. The router will now act as the default gateway for my VMs. If I go to the networking topology page, I should be able to see the router interconnecting both of these tiers. And here we see there's an interconnect router that we created with one leg in each tier. So at this point, my VMs should be able to talk to each other. So let's go ahead and console into my tier 1 VM1, which has IP address of 192.168.1.3, and try to ping one of these two VMs. So once again, this is the 192.168.1.3 virtual machine, and I'm going to go ahead and ping the other tier. So now we have connectivity between two logical switches with our logical router. What about if you wanted to talk to the outside world? So in this case, my VMs can talk to each other, but we don't have a way for us to communicate with our outside world. And these are my uplinks that go to the outside world. So I need to go ahead and add a link or set my router's gateway to one of my uplinks so I can have outbound connectivity from my VMs. Now the way our cloud is deployed and the way we have it deployed with OpenStack and Quantum, by default, whenever I add a interface or a gateway to my logical router, all of my VMs that are behind the logical router will be able to leverage SourceNet and talk to the outside world. We also have a way to establish inbound connectivity using DNAT, which we call floating IP addresses, and I'll go ahead and show that later on. But first, I need to give this interconnect router a leg into one of my uplinks, and I'll go ahead and choose the VMware Interconnect uplink, which is our corporate network, and my VMs will be able to talk to the outside world and everybody on the corporate network. So I go ahead and click on the router again to pull up its router properties. So I pull up the router properties over here, and I'm going to go ahead and set the gateway for interconnect router. My interconnect router will go ahead and select the external network of VMware Interconnect, and we will go ahead and click on Set Gateway. At this point, my router will connect to the external uplink, and under the covers, it will get an IP address from the VMware Interconnect pool of IP addresses on the external network. So all of my VMs can leverage that public-facing IP address to SourceNet out and talk to the outside world. So here we have our networking topology again, and once I set the gateway for this logical router, it has a uplink into my VMware Interconnect, and I have the ability to ping from my VMs through the interconnect router using SourceNet to the outside world. So let's go ahead and verify that as well. We'll go back to our Tier 1 VM1, and we'll make sure that we can ping to the outside world. Great, so we have connectivity outbound, leveraging SourceNet. But what about if I want to talk to this virtual machine, the Tier 1 VM1 virtual machine from the outside? We have to actually give this Tier 1 VM1 a dedicated IP address and use DNAT in order for us to do that. The way we leverage DNAT capabilities are with a concept called floating IPs. And if I click on my Access and Security tab, I have a tab over here for floating IP addresses. I can go ahead and click on Allocate IP to Project, and this button will basically go ahead and it will request a IP address from my VMware Interconnect pool of IP addresses that are available to me. And I will request this IP address to be allocated to myself. So I went ahead and I got the 10.36.4.111 IP address, and now this IP address belongs to me, to my tenant ID. I can now go ahead and assign this IP address to any VM that I want inside of my cloud. So we'll go ahead and assign this IP address to our Tier 1 VM1 port. So here's a Tier 1 VM1 port. I'm going to go ahead and map the 10.36.4.111 to my 192.168.1.3 IP address using my floating IP association window. So now that I have this associated, I should be able to pull up my terminal, and I should be able to ping that VM from the outside world. And I can also SSH into the VM as well. And I'll go ahead and quickly do an ifconfig to verify that the VM is the same one that we have been SSHing into. So once again, this IP address is of my VM1 on Tier 1. So this is the VM that we have been consoling into for our previous validations. So now at this point, I have connectivity outbound, I have connectivity inbound. The one last thing that I would like to demo is our security profiles or security groups feature with Horizon. The security groups are located in my Access and Security tab, and they're under the Security Group tab. And right now I have two security groups created. I have a default security group created, which allows access for everything, which is why I was able to ping and SSH from outside. And I have a web server security group, which I only allow access to SSH and to TCP port 80. If I were to apply this web server security group to my Tier 1 VM1, I will not be able to ping anymore, but I should still be able to SSH. So let me go ahead and clear my terminal, exit out of this VM to start over. And I'm going to go ahead and apply my web server security group to my tier 1 VM1. I can do this by clicking on the Instances tab to pull up all of my VMs. And under tier 1 VM1, I click on the More, and I go ahead and I edit security groups. Right now, I launched all of my VMs in the default group, so I need to remove the default security group, and I need to add my web server security group. I'm going to go ahead and click on the minus to remove it, and I'm going to go ahead and click on the plus for my web servers to add it. So I basically swapped these two security groups, and now my VM will only be able to talk to the outside world on TCP port 80 and on TCP port 22. So we will have SSH, but we will not be able to ping. So let's go ahead and hit save. So now that I have my tier 1 VM1 security group applied, I should be able to pull up my terminal and verify that I can no longer ping, but SSH into this VM. So we'll try to ping this IP address, and you can see that the pings fail because of the security group. And let's try to SSH into this IP address. The SSH should work because I allowed the port 22 as part of my security group. So we'll SSH into that IP address, and we'll put in the password, and we can SSH in, but we can't ping anymore. So our security groups work as well. So now that I've built this multi-tier application manually, I'm going to go ahead and wipe it away, and we're going to go ahead and deploy one from a template that I have created. And this will be a one-click deployment of multiple logical switches, multiple virtual machines, with logical routers that are created as well. Everything will be automated in this deployment, and this shows you how you can leverage the cloud to deploy a multi-tiered application over and over again. It works out very well in a dev QA setting. So let's go ahead and erase everything. Okay, now that I have deleted everything, I am only left with my 3 original uplinks that are always available to me. I am now ready to go ahead and deploy multiple things at once that I have snapshotted previously. Under our Labs tab, we have Snapshots of Labs, which will launch multiple things at once. It will launch controllers, service nodes, everything that I need for a lab. It will create the proper logical networks and the proper logical switches in order for me to have this available. So all I do is click on the Start Lab. So once I start it, I can go back to my Projects tab and start to look at what it's doing. So we already have 3 of the VMs launched. So if I just click on the Instances tab, I can watch my VMs being built on my screen. I can also take a look at the same thing in my networking topology as well. So we'll see the VMs and the logical networks that were created for me. So as you can see, we created 1, 2, and 3 logical switches already. So management network, data network, gateway network, and we have a few VMs that are being launched. And this will continue on. So there we have it. We just went ahead and launched 1, 2, 3, 4, 5, 6, 7, 8 VMs on 3 different networks with the proper logical router and the proper connections between our logical networks so these VMs can talk to each other. This is an example of how I deploy a lab, but it can be used to deploy any multi-tier application with one click of a button.